Yeah, is this any better? Yeah, let me know if this is any better. I'm seeing noticeable difference in my mic stuff. Okay. So I think at some point in time during um during one of the updates, Microsoft decided to be helpful and turn on the microphone for the camera, like within the micro. Um, there you go. Let me. So in here, it decided to default the camera to turn on because it recognizes that there's cameras connected, which means I now possibly had multiple cameras trying to do mic at the same time. So I'm probably getting feedback. So Microsoft needs to stop trying to be so damn helpful all the time. Exactly. I've turned that off like 3 times. And I've got updates ready to go. So chances are it's going to do it on me again after I do updates. So I will remember that and check it out. Go back to intro time. So welcome on into the Dragon's Den. My name is Digital Dragon, aka Luke. I am your host in the Dragon's Den. I'm a 3D print variety streamer here on Twitch, and I'm welcoming you back for part 2 of streaming today. And funny enough, that's twice today where Microsoft's decided to play with my mic. But what is a 3D print variety streamer? Well, we do everything from printer assemblies on this channel, like the Flying Bear Reborn 2, to mods, also like the Flying Bear Reborn 2, which started off with Marlin and wound up with Clipper, to machine builds such as the Voron Trident, the 2.4, whoops, or the other 2.4, to prototyping like the Trad Rack that's sitting on top of the 2.4 and the 0G Mercury 1. This is a full up self-sourced frame build on up. This was done under a closed beta, so also a prototyping type thing. We do some cosplay, and I do have a full set of cosplay armor that is mostly printed. I realized I had a few more parts I needed to print, but I just really need to assemble it, sand it, paint it, and all that good stuff. Obviously not getting done by Halloween. And we have been working on our Voron V0.2 build. So the Voron V0.2 build, and I did mess with that. Second here. We just got this up and running earlier today, and I was having some issues with the thermistor on the toolhead not reading right. And I thought it was a thermistor, so we popped that off. We recrimped, re-terminated the ends, put that back in because I've had that issue once before, and it wasn't crimps there. It was actually my plug on the toolhead side not being fully 100% seated. So there was bad connection to everything on the toolhead, basically, because of that. So, needless to say, we had to reset a few things. And my NeoPixel's off right now. I thought I had fixed all of that. So what I was going to do was set my NeoPixels up like I did for the my V0.1 over here in the corner here, so that it's similar to like the stealth burner where the lights change based on, you know, what's the status. So the front bed light becomes like a status indicator, whether it's idle or it's heating or what have you. So I think what I probably just need to do right now is just come in and physically turn the NeoPixel on. And let's go. Yeah, there we go. See, it works. We just had to give it a color. We'll kind of go to white for the time being. Enough to it. So lights work. That's good. That's good. So let me come over to our browser window. Of course, why would that set up to the right window? Hey, Major Gamer Geek, thank you for the resub, my friend. I appreciate that. 1, 2, and now 3 months. There we go. So yeah, welcome back in, everybody. Thanks for bearing with me on my weird mic issues that are just annoying. But that's Microsoft for you. So we had everything assembled. We had the electronics there, and we did the software portion this morning on stream. And we brought up the interface, and we were getting really weird readings on the extruder thermistor, like negative 17.6. And it was causing the interface not to come up. Once I looked at Clippylog and I realized it was reading negative, I set the minimum temperature to like negative 50 and at least got the interface up to see, yeah, we're getting very weird temps. So I tried redoing the connector for the thermistor. That wasn't the case. And then really looking at it, I realized that the connector here for the Picobillical, it's a 14-pin connector that goes from the toolhead board up here to this backplane board. The toolhead board wasn't fully seated. So once I got that fully seated, everything was working as anticipated. So now what we're doing is we're just going to kind of go through some pre-flight checks and see if we can't, I don't know, get some plastic to come out of the nozzle tonight. And then Tuesday we'll just come in and do some printing on it, maybe slap some skirts on it because she's looking a little naked. We'll still have to work on panels and stuff like that. So Monlight, the issue was the 14-pin connector at the tool head was not fully 100% seated. So I was getting a loose connection on the pin. So that's why, because your thermistor is a resistance reading, if your connectors are loose in any way, shape, or form, you'll get a different reading. Yeah, and so that was it. I thought I had it fully seated, but so microfits are, especially like these 14-pin microfits, I mean, you've got to really like almost clamp on them to get them to fully seat the first few times because they're just, yeah, I mean, you're trying to line up 14 pins at the same time, and those connectors and the wires can shift in the housing just ever so slightly. And it's just hard to get them seated the first few times until you kind of break in the connector. But preferably you get them in there and you never take them out. So yeah, exactly. I got you. And that's where when I looked at the Clippy log and I saw that the temperature reading was a negative number, that's where I knew that increasing the max temp wasn't going to fix the negative number. But we're up and we're running, and we're good at the moment. So that's good. We're getting pretty close. So we're reading 25.8 and 25.4 on our thermistors. In fact, how about we do this? How about we go back to full display, and I've got the printer down here in the lower left, so you might be able to actually see and read the screen a little bit more. So that might be better. Oh, nice. You only plugged in half of your pins. Well, that would yeah, that would cause your heater not or your fan not to work right. Okay, so we're plugged in. What we're going to do is we're going to go through our initial checks. And basically it tells us just go to the Voron documentation and just kind of work our way through the initial checks. We've done this on several printers by now, but we're just going to go through and do these initial checks. This talks about the interface and where you need to go in the interface to do some things. We're going to start by verifying the temperature, which is where we basically started off today. All right, cool, mod light. And validating that our temperatures or our thermistors were working. So we're getting good thermistor readings now. They're not increasing. They're sitting there pretty stable. They're bouncing a little bit, but it's 25.8, 25.4. We're pretty close. So what we're going to do is we're going to tell it to heat up one of the heaters, and we just want to make sure that that heater does actually start heating up. So in this case, it's going to be the extruder. And the other thing with the extruder that you won't be able to tell unless I move the thing in closer is when I tell it to heat up over 50, the cooling fan should start. When I tell it to cool back down, and once it hits below 50, the cooling fan should stop. So we're going to go ahead and hit go. And we're seeing that it's applying 100% power and, well, some percentage of power, and that reading's going up. And our hot end fan did just kick on. And I will bring you guys up here a little bit closer so that you can see that hot end fan is indeed working. Okay. And now I'm going to tell it to cool back down. And as soon as that reading goes beneath, well, not as soon, but as it drops below 50 by a couple of degrees or points of a degree, you'll see this hot end fan drop off. And that tells us that the configuration for our hot end cooling fan is working as intended. Getting there, closer. And this did come with some initial PID tune values, and we will rerun the PID tune on this. And there's our fan stopping. So our fan is working exactly as expected. So that's good. Now we're going to do the same thing with the bed. We're just going to tell it to go up to 60. We won't let it go all the way up, but we're just going to keep our hand on it to feel that it is actively getting power and heating up. Thermistor is rising. Got power set to 100%. Yes, this V0.2 is running a Picobillical. This is an LDO Motors V0.2 kit. And that Picobillical basically means that it's got a Raspberry Pi 2040 chip on it, just like the SKR. the SKR Pico board that we've got running in it. And so, yeah, that is warming up, so that's good. So we worked through that earlier on this morning's stream, which I haven't posted over to YouTube yet, but it is up on, it should be as about, or no, I haven't published it yet on Twitch, so I need to do that. And yeah, that was interesting because running two different boards that are RPi 2040, so you have to disconnect one as you flash the one, and we're able to flash everything from the Pi because the 2040s, you're able to basically put it into a, I was going to say DFU. It's not DFU mode. It's a UF2 mode, I believe it is, which basically makes it look like a disk drive, like an SD card. And so we were able to get both of those added as an SD card and basically flash it as if it was an SD card. And that flash is like that, right? So our heaters are working well. Grab this and move it over here out of the way. We just verified our heaters. We want to do our stepper buzz to make sure that our motors work in the correct order. So we'll just copy that command. Whoops. Come over here and paste that command. This is stepper buzz, stepper underscore buzz, space, stepper equals, stepper underscore X. And when we do this, the X motor, which is our left motor, should move clockwise and counterclockwise. And it's only going 1 millimeter, so it's really not moving much, but you see it go right, left, right, left, right, left. So this is moving in the correct direction. Probably put you guys over here so you can see this better. Bear with me. We'll go through and redo that again so you guys can see that. And it does it 10 times where it moves one way then the other. And it wants to go right then left, right then left, right then left. And then on the Y, it's going to go in the positive direction. So it's going to go back then forward if we're set up right. And that's just going to be stepper underscore Y. And I'll bring you guys around here a little bit so you can see from a side view. Whoops, possibly side view. Nope. View. See if this will show it to you. So it was moving the right direction. Whether you guys could actually see it or not is a little bit different. We're going to go ahead and do stepper Z, which will be the bed, and the bed should go down then up. And you should be able to see my finger here as it's riding on that bed going down then up. Okay, so far everything seems to be moving in the right direction. Hey, Zombie, yep, 4A. We're just going through and doing our initial checks to make sure that things are working in the right way. And really what I'm going to need to do for the next one, which is to check our direction on our extruder, is to put a little bit of filament down in there. Filament down in, please. Probably shouldn't use a piece of filament that's highly curled. There we go. And push in your side and then latch down. And we're going to do the next one, which is stepper equals extruder. And we're looking for the extruder piece. So we're looking for this to go in, then out. And it's going to probably go very slowly. So I'm just going to stick my finger on it and see if you can tell. And it's going out, then in, which means it's going the opposite direction. This has kirigami, and no, I have not leveled the bed yet. So because our extruder is going in the wrong direction, we're in an add. We need to come into our printer config. Roll down to our extruder. And our dir pin here, it's got no exclamation point. So we're going to add an exclamation point, and that changes the direction. Might do one of the servo probes. Okay. There's a part of me that was thinking of like, ooh, can I do boop on this? But no, you can't do boop on a standard V0 because of the springs. You need either like a micron, a salad fork, or something like that. I mean, you can do like side swipe, and I do have a side swipe kit that I could put on here, but this is going to a maker in need. So I don't want to make it any more complicated than it needs to be. That makes sense, Zombie? I'm just going to tighten the springs down some because eventually we'll be getting to that section. Yeah, like I said, I have a side swipe, but the problem with doing side swipe is it adds complexity. And I know this is going to get shipped and then it's going to go to somebody else. So it may, I think the bed springs are just as good as doing side swipe when I'm not sure who's getting this end result. So because the direction was going the opposite way, if you've got if there's an exclamation point there, you would take it out. If there isn't an exclamation point there, you would add one in, and that just changes the direction. And then this is the nice thing about Clipper. I added the exclamation point to change the direction. I'm going to hit save and restart. Back to my dashboard, do an up arrow, and I'm going to check this. And now it's going in the right direction. So exactly. So our extruder motor is going in the right direction. And that's the one I normally forget to check until I'm actually getting ready to do calibration and then figure out why is it not working right. So I'm going to open this up, take said filament back out, that back in there, close that down again. Talks about adding or removing the exclamation point. What's up next? Query endstops. So you can do a query endstops. Here in the console. It tells you X and Y are open and Z is open. Okay. Or you can go to the machine tab scroll down to the bottom and you have an endstops down here. And you click on the little refresh window and it'll query your endstops. So X, Y, and Z are all shown as open. Okay. And our Z endstop is down here at the bottom. So what I'm going to do is I'm going to trigger that manually with my finger and run the check. And Z is triggered, so that's good. That means Z will trigger. X and Y, we won't get a triggered endstop because we're doing sensorless homing. Okay. One other thing that I need to take a look at is our filament detect sensor is not set up just yet. So we're going to come into our printer config and just going to scroll down here a little bit because our filament detect sensor should show up as one of our end stops because it's actually an end stop. And I want to scroll down here. There is a section by and here bed. Oh, at least I thought it was down here. Maybe it's down on the umbilical side. Yeah, it would be down here because it talks about the filament sensor, which is up on the front board in case you're running a filament sensor on your tool head like a orbiter or something. What I wanted to heat is basically what I was looking at. I'm going to grab this set of code for FS filament sensor 1 in the frame PCB. I'm going to scroll up here to the top above where the Picobillical setup is, right? And it doesn't matter where, I just need to get up here and throw in a comment section. I'm going to paste that code. Uncomment it. Okay. And we're going to change this to filament sensor 0. And instead of frame PCB, we're going to call it right rear foot. Because remember, on the right rear foot of this printer, we have that filament sensor that we installed. Filament switch sensor, runout sensor, we can leave it like that. And we're going to take the UMB prefix off because it's plugged into the main SKR Pico board. And we need to get the right GPIO pin, which I'll bring you guys back up and out here. So once again, we've got the, over here in the right rear foot, we've got a filament runout sensor that we installed. And we plug that into the endstop 0 so we can look at the schematic diagram that they provided on the box to figure out what the GPIO pin is on the main board. And the GPIO pin is, I believe it says 16, but I'm going to have to get out my old man glasses because apparently my bifocals are not enough to confirm that. Yes, IO 16. So we want it to be GPIO 16. Right? Then we'll save and restart. And we should be able to scroll down here and check our end stops again. And we're not seeing a filament runout detector. Pretty sure it showed up down there. Maybe it doesn't. Runout sensor. Shows as empty. Now I'm going to take the filament that I have sitting here and I'm just going to push it in until I feel it trigger the sensor. And you see where it now changed down here to say detected. That means that it's triggered the sensor, but I don't know if it's triggered in the right way or wrong way. It should be triggered anytime there's filament there, and as soon as it backs out, it should trigger the runout detected macro and kind of go into a pause state. So that's good that we're at least seeing that triggered. Homing check. So at this point, everything's ready to home the X and the Y. Be ready to kind of hit the E-stop in the interface, and we're going to run them basically all separately, right? So we're going to use our toolhead interface here on the left. Thank you for doing the shout out to KB3D there, Zombie. And yes, we got a Bang Polymaker. Thank you there, DaVinci. I do have affiliate links for Polymaker. And I also have an affiliate link for KB3D, so I'll have to check that out. Yeah, I don't know why I don't have my affiliate link there. I should fix that. Yep, live again, Chewy. And we're just doing our initial checks. So what we're going to do right now is we're going to home X, so it should go to the right and home when I click home X. And it goes the right way. So that's good. We're going to home Y. Went to the middle. So we're going to home Z and it should go down. So what it did is it went all the way down and now it's coming back up to its preset height, which should be 20 millimeters from the 0 position. Okay. So each one works separately. Now we're going to do all at the same time. And we're homing. So another check mark down. Everything was moving in the right direction, so we don't need to worry about changing anything. Our directions were working right. I think that's the first time ever for me on a Core XY that it worked right. Now we have a bed locating section. This is for V2, V1, Trident Legacy. We can skip that because we're working on a V0. Find 0 point for V1, Trident, V2, and Legacy. Oh. The end stop pin location? No. The end stop location for a V0. V0, V01 uses the bed assembly to contact the Z end stop switch via an adjustable screw on a T8 block in the back. The V02 Z end stop is located at the bottom of the machine. So we're down here in this section here. So after homing, you can use the endstop calibrate command to find the correct position endstop value automatically. Use a piece of copy paper, set the height of your nozzle relative to the endstop position. Do this test with your nozzle cold. Nozzle is heated, its position relative to the bed changes due to thermal expansion. Thermal expansion is typically around 100 microns, which is about the same thickness as a typical piece of paper. The other thing I'm going to do is just unscrew each of these just a few from being fully tightened so that we will have some adjustability down the road. So here's the trick. We're at 20. If we do the Z endstop calibrate right now, we're going to start from 20 and start doing that calibration up, which means we've got to kill 20 millimeters. So what I'm going to do is actually do a G1 Z go 10 F 3000. And that just moves us a little bit closer before we start the process. And I use a Post-it note. This is a Post-it note from Chris's basement that he had printed up specifically for doing these types of things. I just fold over the sticky part and then pick up a leaf so I can have something to grab hold of when I'm trying to adjust it and feel the tension. Okay, so now we're going to do a Z underscore end stop underscore calibrate. And as you can see, we're going to start right there wherever we were at. So we're going to start moving down in increments of one full millimeter until we get close. And right now I can just kind of eyeball it. All right, we got snug there, so I'm going to go back down one. Now I'm going to just go down to the next increment, which is a negative 0.1. Okay, I'm starting to feel it there. Now I'm going to drop down to the next increment, which is 0.05. Hey, thanks, Zombie. And I like this. This is good. This is good. I don't need to go anymore. Maybe I'm going to go up 0.005. I like that amount of tension right there. All right, so we're going to say accept. And what that does is it sets the new Z endstop position. So the amount of travel between the nozzle and the Z endstop. And it's going to set it to 118.745. And it says the save config command will update. You can either copy save config, paste it and run it, or click save config up at the top. Hey, Stephen Poole, welcome on in. And that will save that new value at the bottom of your configuration file. Okay. So we've got that set. Next up, I really hate that this is in red because red on black is hard for me to read. This is the inductive probe, which we do not have on this printer. We don't need to do probe accuracy. Next up will be PID tuning the bed and the hot end. So I'm going to get this command ready. This is going to PID tune the bed to 100. We might change that down because we don't have the panels on. What I'm going to do though, before I start trying to PID tune that bed, we're right up against the nozzle. I'm going to drop the bed down some. I was going to attempt to drop the bed down some and it won't let me, so I'm going to home it, which will give me some distance between the bed and the nozzle, which is what I was going for. You never want to do your PID tuning with it right next with the nozzle right next to the bed, um, because once again, thermal expansion. So if we do 100, it's going to try and bring this bed up to 100. We're not going to be printing enclosed at that high of temp right now. We're going to be spending some time just pushing some PLA through it until we put all the panels and build the top hat and all that. So I'm going to drop this from 100 down to 65. And we're going to start. Hey, Creatix Brit. How are you doing tonight? Shout out Stephen Poole. Stephen Poole does a lot of amazing prints. His machines are really, really dialed in well. He does a lot of prints. I believe he used to print on MakerDeck. I'm not sure if he still prints on MakerDeck, but he normally streams. In fact, he's probably streaming right now 3 or 4 prints going on his printers. And then Creatix Brit, aka Nerd, is another really, really cool maker in the community. I believe last night she was doing Legos with her daughter, who was so cute, by the way. And she does all kinds of cool cosplays and 3D printing as well. She's a designer, so she's starting to do some design work along with Photosmint, doing like some bases for his models. And what are you, a creative or marketing director or something like that with Photos at this point? But you're starting to do your own design. She's got a lot of pennants and stuff, which are really nice. And she's got the monster jar, which is really awesome for a holiday themed, like, I don't know, Halloween. You're his art director. Yes, there you go. That is the title. Yeah, go check out Creatix Brit and all the cool things that she's working on. So as we're doing this pig calibration, you'll start to see the bed's heating up, and it's going to heat up to 65, and then it will stabilize, and then it'll drop the temperature like 5 degrees, I think, and then heat it back up to 65. And it's going to do that 5 times. We just started the pit of the bed, so it's heating the bed up, and yeah, it's getting hot. But it comes up to that target, in this case 65 degrees Celsius, and it will hit that temperature, let it solidify, and then drop it back down 5 degrees, and it'll go through that cycle 5 times, and then take that average, and each time it's going to get closer. And it came with a PID tune on it, but it's always good to re-PID because they're using basically factory defaults. So oh, not a problem, creature. You're always giving me kind words. Least I can do is give them back. So you can see now that the temperature target has changed down to 60. So we're dropping that 5 degrees, and then it will heat back up. And each time it's going to get closer and closer to hitting those targets without over or undershooting, right? And then once we're done doing the bed, we'll go ahead and save the config, and then we'll come back and we'll PID tune the hot end. Yeah, and once when I ended the stream earlier today, one, it was a good timing because it was right when shortly after Steve started, and I wanted to jump over to Steve's commemorative stream for Charlie, or memorial stream for Charlie, and it was really great because we kept digging through his old videos and pulling up different shenanigans of Charlie. Um, oh, no worries, no worries. Did you butt in between me and Zombie? Oh yeah, yeah, no worries there. No worries whatsoever there. Yeah, I was in the process of explaining that myself. Is because this is going to a maker in need, I don't want to do anything more than adding a filament runout sensor because I think one, that's a very easy mod and it's a quality of life thing. Putting something like a probe on, like a side swipe probe, there's too many things that could go wrong with that that would cause damage to the machine. If the probe timing was off or something, or the servo timing for flipping it out or flipping it back was off, you could damage things. And quite honestly, the Kirigami beds, I don't have too many issues with these beds. Um, so yeah, I mean, he was asking, and this has been the first time that I've built a machine that I knew from the time it hit my house or the time that Chris gave it to me at Earth that it wasn't for me. It's going to somebody else. And that if this was me, I would probably have a lot more mods on it than what's here. But it's all good. It's all good. Um, so you can see you can't see too much, but our peaks here are evening out. It's not as sharp in the gradient there. So that's where it's starting to make those adjustments in the software. And there is no coffee tonight right now, gang. I'll give you that heads up because I've had two 20-ounce Yetis and that like 20-ounce. It says it's a 15-ounce, but yeah, I need more on my stomach before I drink more coffee today. Yep, no worries, Mod Light. No worries. Oh, it's not about sleep. I took a nap earlier. It's just I know my stomach, and if I drink too much coffee without having good solid food on it, uh, yeah, that turns bad. I think anybody with just coffee on their stomach probably goes bad. Yeah, I know. I was so mad. So while this is PID tuning, this one takes a long time. The hot end goes really easily. So me and my mailman are going to have words, and I'll see if I can't bring this up. So here's the box that he shoved in my mailbox, right? So I've got the kiosk. So there's one mailbox for everybody in the neighborhood. So it's kind of like the apartment kiosk stuff. And he continues to shove boxes in there that just barely fit into the slot. The problem is I'm at the top of the door. So what you're seeing there is my finger like this up touching the top of the box, which means you can't see my fingernail. So there's at least a 1/4 inch where there's a lip at the top and the bottom. So I can't get the box out. And I knew what was in the box. And trust me, I'm going to be going down to the post office and having it out with them on Monday, because this is not the first time and I'm getting tired of it. Not only that, but he puts that box in the mailbox and then brings this box up to the front porch and sets it at the door. I'll be kind to the postmaster. I want to wring the neck of the guy that delivers my mail, which is a contracted courier. And they need to find a new contracted courier. But what was in said box was my Raspberry Pi 5, right? And yes, that is a 8 gig Raspberry Pi 5 with a case, the active heatsink cooler. And this is what I like, a 27-watt power supply. I could plug my laptop into this. So, yeah, needless to say, I was not going to let this sit in the mailbox over the weekend. So I wound up having to cut the side of the box, open it up, take everything out of the box one by one, and then basically crush the box down to get the box out. I was so annoyed. But like I said, he's done this to me multiple times. And I'm tired of this dude. Hell, I've caught him leaving the neighborhood with the mailbox wide open so that everybody's mail is available. I didn't take a picture of me cutting it out, but I'm going to have words with him. I will explain to him that I had to cut the box open to get stuff out. He does the same thing with my alien boxes because they can fit right in the slot. But then as soon as you close the door, you've got that lip and you can't get it out. And it just, I'm frustrated. And my wife's left notes to him 2 or 3 times saying, stop putting the boxes in there. And the other thing that gets me mad is there's there's the 2 parcel bins. He won't even put it in the parcel bin, which I don't get, because he'll bring my coffee to me now and set it on the front porch versus putting it in the parcel bin. It's like he doesn't want to use the parcel bins. I don't get it. I just don't get it. But I did some checking, and I think I might have the Stream Element stickers and the Stream Element mug. Well, the stickers I think might be here before Tuesday. The mug might get here Wednesday, so we might not be able to see that until Thursday. And I have zero idea how it's going to come out. So hopefully it's decent enough, because KB3D Chris has already bought a mug. So hopefully it's good. Yeah. Yeah. They're just being lazy. But I don't get why he would bring one up to the house and then cram the other one. Like, yeah, I don't get why he would bring one up to the house and cram the other one in the box. If there was 2 boxes, I would have brought both of them up to the house, you know. Okay, I think we still have 2 more cycles. So what are you working on tonight, Britt? Anything fun? Are you still working Legos and just trying to get better? Oh, and Chewy, that box that I showed, that big box from KB3D was parts for your build. Bolting. Okay. Like, are you doing another pendant or just anything you care to share, just the topic that you're sculpting? Because I did see your 3 new pendants, and I got to go pull those down and try and print those to see how they look. So while it's doing that, I think I've got enough cable. Let me pull this back out. It was just barely in there anyhow. And we will turn this around so you guys can see the electronics. Ugh. Bring it in a little bit closer too. So once again on this build, we've got a Big Tree Tech SKR Pico. All right, so the nice thing about this board is almost all of the connectors are on the outside edge. The only thing in here are the E0 end stop, which is normally used as a filament runout detector like we're doing today, and your RGB lights. Everything else comes in from the exterior of the board, so you can mount your Raspberry Pi right on top of it. Now, if you're going to do that, you really need some good active cooling on it because it's going to get hot in that form factor. But the other nice thing, and I've done this on a couple of my builds, is you can mount the 0 right over one side or the other and pull power straight from the top of the board here into your Raspberry Pi, and it's a nice tight all-in-one package. And then on this side, we went with a Raspberry Pi 3B. For those that weren't here this morning, I made this decision because the 4-port USB extender board that is designed, well, I don't know if it's specifically designed for this, but that would work where you would put a Raspberry Pi 02W on top of that board and then power it that way. The only place I can find those boards is in the UK, and there's no way it was going to get here. So I grabbed a Raspberry Pi 3B, and that's what we're using today on this build. And then the other board that we have is this Picobillical that sits right between the 2 motors. And this is another Raspberry Pi 2040 board, just like the SKR. And this provides all of the connections to the toolhead. So it takes 24-volt power in because it is another controller board. And that's what we pull the 5-volt power out of to power our Raspberry Pi. And then the extruder motor is a direct pass-through. So this is the extruder motor cable right here that comes down and plugs into the SKR. Unlike a CAN bus board, which would be an MCU at the actual tool head, and then just 4 wires that comes back. This has a 14 pin between the tool head and this board here, and then it just passes through the extruder motor. So that's pretty cool. And then once again with our tool head board right here, everything on this tool head connects right to this board. You can disconnect this 14-pin connector either here or at the Picobillical board, and one screw in the back, two screws from the front, and this whole tool head comes off the carriage, and you can take it to the workbench to work on it. So if you've got a busted fan or anything like that, it's really easy to just take that tool head off and go work on it. And that's those I'll say those quality of life things that you get in an LDO kit that you might not get in other kits. Okay, so our bed tune finished, and I don't know if you can tell, but each one of these peaks is just a little shallower, which means it was really fine tuning in the power and how it modulates the power. Okay, so we're going to do a save config, and it's going to save those parameters and then reboot, or not reboot, but restart the Flipper software. And then we'll come over here and we'll grab the paid calibrate command for the hot end. Paste that in there. Now this goes to 245. That's actually not bad because once again, the hot end heater heats up a lot quicker. So it should still be pretty quick. And the 245 will work for your PETGs as well. And as an open air printer, the way it is sitting right now without the panels on and the full enclosure, it's good for PLA and PETG. So we're going to go ahead and run it at this target of 245. And 245 is pretty close as well for your ASA. I mean, it's the lower end of an ASA or ABS. You'd want to really be printing at around 250 to 260 for those. So you're close enough that it still works for those. It's a good happy medium. Mission for the 3DP Awards. Nice. Nice. Now, is this going to be you're submitting trying to get one of the awards, or are you submitting this as like the trophy type, like a trophy design that they would use to give out? Major Gamer Geek, how have you been doing? Hope you've been doing well. No, I need to. We're making plans. Me and Mrs. Dragon are making plans on how to get things to Rocky Mountain Rep Rap Fest, because I think she may be driving out, but if she drives, she'll take the Kia Soul, so I won't have as much room to take stuff out there. I'm really fearful of her driving my truck. Probably online and heard me say that. Probably take some crap over. And I'm probably going to be driving. The reason she may drive out and then I'll fly out, and then I may be driving back in a moving van, bringing some of her mom's stuff back to our house because her mom's moving into a smaller place. Oh no, Mod Light, that sucks. I was hoping to see you at Rocky Mountain. Because Rocky Mountain's probably closer than MRF, right? The Midwest Rep Rap Festival for you? Money, yeah, I get that. Okay, so as you can see, that was a lot quicker for this hot end. So we're going to go ahead and save that config again. So we've got both of our heaters PID tuned. Next up would be bed leveling. So on the V0, you would do a bed screws adjust. It basically uses the manual bed leveling. So what we're going to have to do first is, because we just did a firmware restart, is we need to do a home all so it knows where it's at in relation to the bed. We're going to do that home all sequence. See if I can't bring you guys a little bit closer here. Okay, so we've homed. Now we're going to do a bed screws adjust. Command. And what that's going to do is it's going to go to the 3 points and we'll start adjusting our bed screws, hence the name, until we get the right tightness level. So that feels fairly tight, but I'm going to tighten it ever so slightly. So I like that. We're going to click on adjusted. So every time you change one of these 3 points, it adjusts the height on the other places. So right now that is very, very tight. So I need to go clockwise. Well, yeah, to tighten that screw down. I like that for now. We'll say adjusted. It's going to go to the other side. Same type of thing. This one isn't there, isn't even close. So we'll loosen the screw over here so that bed spring can push the bed up. I like that. So I'm going to say, whoops, adjusted, and I'll come back to the front. And you want to go around 2 or 3 times to make sure that you're getting, like I said, a good, nice, and even um, hug on your paper. And when you like it, say accept. Now, if I do a very, very small fine tweaking, then I'm fine with hitting the accept. But if I'm like turning a quarter turn or more, I'm going to say adjusted. That one's good. Good. We'll hit accept. And we should be good. So we've got that completed. I'm going to go ahead and do another home once again, just to keep the nozzle away from the bed. We don't do the bed tilt for a V1. We don't do a Z tilt. Don't do a quad gantry level. That section doesn't apply. You do not run PID tuning. Set your extruder to 245 and heated bed to 100 and let the printer heat soak for 15 minutes. We shouldn't need to adjust that. That would be for our big boys. It says to redo it, but we're close enough and really don't think we need to rerun it hot. I mean, we can heat things back up. 245. We'll go back up to 65. We'll let that heat up, and then we'll move it closer to the bed. We'll do another Z end stop adjust with it warm. Hold on, lightning. So approach the vendors. So here, let me do this. Not what I wanted. We'll do this while it's heating up. I will say approach the vendors, right? Reach out to the vendors via Discord, Twitter direct message, email. Don't just go out on Twitter and just throw a blast that says like, hey, I'd like to go to Rocky Mountain. Who would like to sponsor me? Right? Reach out to them directly. That's how I've gotten some assistance with some of my builds is I've reached directly out to LDO Motors. I reached directly out to Big Tree Tech. I reached out to Tensor 3D and KB 3D. And I started off saying, hey, you know, I'm working on this build. Could I get you to, you know, sponsor a couple of components that I would need for this build? Right? That way we're getting a little bit from here or there, but I'm not asking somebody like, hey, can you send me a $2,000 printer? By the way, thanks, Chris, for sending me the black box that's coming shortly. Probably next month. Well, yeah, it's going to be next month because it's not going to get here in 3 days. So thanks, Chris. But you build up that reputation with them and you reach out and when you go out to them publicly, it kind of puts some pressure on them when you reach out to them a little bit in the background and say, hey, you know, here's my concept. This is what I want to do. If you can help me get out there so I can highlight some of these smaller makers in the community and stuff. And I will also give you airtime and, you know, do some plugs for you throughout the show or something like that. You'd be surprised how amiable they are to doing that. And a lot of them, like Chris made that comment on his stream last night. I'm like trying to, God, yeah, on his stream last night of, he loves helping out the smaller makers, right? That's why he was reaching out to me and working with me on some things. That's how this came about is, you know, I'm smaller and we're giving this out to a maker they're in need to try and help them out. So yeah, I mean, that's kind of what he does and what we want to do. And you know me, I mean, I'm going to help out anybody. I will help out anybody. And I did get the that CAD piece. Yeah, definitely talk to Chris. I did get that CAD piece from you or the step file or F3D file or whatever, so I will look into that. I've got a thought rattling around in my head on how we can do that, but um, just with the dimensions and where those holes are, I don't think that I could switch those out to heat set inserts because there's not enough meat around those corners. But I have a thought. So I I have a thought. You got someone who mod? Okay. Oh yeah, Major Gamer Geek. And like I said, I reached out to Jason at LDO Motors and just said like, hey, can I get, would you sponsor an order or two for this build? Right? Something small. It's a, I don't know, what is it, $50, $60 extruder, and that worked. And he sent me that because it was a small ask. Now, if he doesn't know me from Adam and I'm not out there, I'm like what, a couple hundred followers on Twitch and YouTube, I'm not big. I don't have the big names. And if I go out to, it's one thing if I'm going to Jason and say, hey, I've got this idea for this new concept, let me pitch it to you and see if you can work and help me refine it. Now that's one thing, right? But for me just to go and say, hey, I, I'm I'm a nobody. I've got, you know, 10 followers on Twitch. Would you give me a $2,000 printer that I can build on Twitch so that, I can help get my numbers up? Hopefully they just open their marketing budget for the year and you might stand a chance. Um, um, gotcha. Oh, hey, Mrs. Dragon. Okay, so if you guys were here this morning, we gave a shout out to my brother-in-law, um, Eagle. Um, he was doing regional tournament for uh, Special Olympics for bowling in Colorado today. And Mrs. Dragon just jumped on to say that Eagle got fourth place. That he could have been more if he kept his eyes open when he threw the ball, but little things, little things. Easier to hit your target when you're looking at your target, right? But yeah, that is great job. Very good job, Eagle. If you're sitting there listening with your sister right now, great job, guy. Thank you. That's thank you for going out and doing that because I know, how can I put this? I know you like going bowling. I know your sister can be a distraction when you're bowling. Um, but thanks for letting her come along. I hope she got some good pictures out there. Um, but yeah, so we're going to do another Z end stop. If I can spell it right. Another Z end stop adjust. Oops. Or I'm sorry, not Z end stop adjust, it's Z end stop calibrate. Besides, I want to raise this up some. Oops, going the wrong way. Get a little bit closer. Z end stop calibrate. There we go. So now we're 5 millimeters away. We're heated up. We're going to start getting closer. I mean, we're right there. That's pretty tight. We are on a textured sheet. I'm going to actually raise it up a little bit. Probably easier if I put you guys down here so that you can see what I'm doing. Yeah, so I got it adjusted. I got a little bit of movement there. It's fairly tight still, so I'm having to give it a little bit, but I think that'll be good, especially on a textured bed. So we're going to accept that. So we made a minor adjustment. We're going to go ahead and save config. Once again, I'm going to leave this paper here to keep the contact difference between these two. And I'm going to do a home real fast. Because once again, this if you've ever used tap, right? It's got a macro that prevents the tool head from doing its probing against the PEI sheet if the tool head temperature is over 145 degrees or 150 degrees Celsius. Anything over 150 degrees Celsius, and you can start damaging your PEI sheet by contacting it with the tool head. So definitely keep an interference there even after you do your reset, because your temperatures are still high. And as soon as the firmware restarts, do a home, which will put you that gap in there again, and you can move your paper. Got another ad break in progress. It's almost over. Welcome back in. Welcome back in, everybody. So Mod Light, that's where I said go out to, like, find Fadus or find LDO Motors on Twitch, or go to their vendor website and they should have a contact. Sometimes they have a marketing contact specifically for marketing requests. So, try and find those. And sometimes it's a bit of fishing, right? So you send an email out and say, hey, I would like to talk to you guys about this. Who can I talk to? And you just have to play that waiting game for them to respond. And, give it a week or so. If you don't get a response, throw it back out there again. It's like, hey, wanting to bump this up into the, back up into the top of your email inbox. I'd like to talk to you about this or that, because some of these vendors, like Luke with Big Tree Tech, he's really, really busy, and he's getting a lot of email and Discord DMs and stuff like that. So it takes a little while. I was reaching out to him ever since Earth, and he finally got back to me last week on a couple of things. And it's, it's not that they're, I'll say, ghosting you or ignoring you. It's just literally some of them, are one single focal point, right? And it takes a little bit of time sometimes for them to get back to you. Don't get discouraged, just keep trying. So we redid our Z calibrate. Telling you, how to do it with the LCD screen. We don't have an LCD screen attached. Extruder calibration, aka E-steps. So this is where it's going to be best to not run through your reverse Bowden tube and just go directly in. And if you happen to have some filament from the end of a spool, just make sure you leave one around occasionally, because you never know when you might use it for something like this. So just snip it and give yourself a good end to start with. Try and get some of the, straighten it out some. Open our extruder up and insert this down. There we go. I have it down at the, all the way down in the nozzle. And what we're going to do is we're going to take our ruler and our piece of tape that we use. This is it. So I always use a piece of tape with the factory edge here, and I put it at 120 millimeters on my measuring device. Okay. Now, this is a relative measurement. So mine starts right at the end. So my measuring starts right at the end. If you're using a measuring device, say like this. Here, let me go big screen. Try and go big screen. So hit the right button eventually. So if I'm doing like this, where my measurement starts right at the end, where I can put this on something and I'm measuring the right distance, that's great. But even if I'm using something like this, where it's offset from the end, don't worry about it. It's no big deal, because what we're doing is we're still measuring from that end point. We're going to put that end point right at the top of the extruder. We're going to pull this up straight, and we're going to just take that tape and put it right on to our filament. So regardless, that's our measured 120 millimeters, right? That's our measured 120 millimeter along our measuring device. When I heat this up and then I run 100 millimeters through, I'm looking for that same measurement from here to there of being 20 millimeters, regardless of whether there's an inch before the first marking on this happens, right? Because it's all a relative measurement at that point. So what we need to do is come back over here. We're going to heat our hot end back up to an appropriate temperature. In this case, this is a silk PLA. I'm going to go ahead and just go to 210. And we'll go back to this screen. So that's what I'm saying. You can do a search on Twitter for like Fadis or LDO, things like that. You can ask trusted people like me if I have some contacts. You can go out to the vendor website like Big Tree Tech and look for the About Us or Contact Us, and that is a direct into the company versus just throwing something out into the community type thing. Oh, thanks, Subsector, for stopping back by. And yeah, that house flooding thing. I haven't had a full house flooding, but I have had like I had a basement in Colorado, and in heavy storms, the sump pump and the window well would pump back up into the drain. And what we finally figured out was the drain pipe about halfway down the front yard was completely blocked. So once that drain pipe filled up to the main pump point where the sump pump was pumping into the drain collector, that would fill up, and then gravity would just pour it right back down into the well. So it was basically like I had a water fountain going in my window well. and we never had it encroach into the house, but we would be out there in the middle of the storm with buckets, like bailing it out manually, trying to keep it from flooding into the house. So I get you. I get you there. So we're up to temp. And now what I want to do is come down to my extruder section. We're going to click on 50 millimeters. And you can do it at 5 or 2 or 1. The slower you do it, the more accurate the stepping will be. I'm going to go down to 2. It'll take a little bit longer, but so be it. And I'm going to move my bed down a little bit more, just give me a little more playroom there. And we're going to say extrude. And it should go through and extrude 50 millimeters, right? Make sure it is going the right way. Do you have any Flex Seal? Like some of the Flex Seal tape? It might do good in a pinch to seal it off initially. All right, so I think it went and did the first 50. Now we're going to hit extrude again and do another 50 millimeters. Okay, there you go. Yeah, I've got some, I have a couple of spools of Flex Seal, or spools, a couple of rolls of Flex Seal in my truck, because when I went to Murph, not earlier this summer, but last year, I took a, like it looked like a lug nut off of like a construction vehicle, like a big dump truck or something, to the windshield going through Virginia. And it started to spider out. So I had actually stopped to get some Flex Seal, and if it was going to start raining, I was going to just put Flex Seal along the inside of the window to try and keep it from leaking. And when I got to my son's house, I called Safelite, and they actually came out and fixed it while I was at the show. Okay, so we put 100 millimeters through. Now what we're going to do is we're going to lift this up straight again, and we're going to take a measurement. And I am measuring 17 where I should be measuring 20. So I actually over extruded 3 millimeters. Yeah, that's the nice thing with Safelite is you can pretty much get them anywhere. So we've got a calculation that we can do here. And let me make this full screen again so you guys can actually see it and hopefully read it. And so what I'm going to do is go into my calculator on my phone, make sure it's cleared out so I don't have any residual here. And you're going to take your old config value that's in your printer config file, and you're going to multiply that by your actual extruded amount minus the target extruded amount. So once again, I had 17 millimeters left, which means I extruded 103. So I'm going to put in 103 divided by 100. And of course, that equals 1.03. And then we need to multiply it by the old config value. So we're going to go into our printer.config, scroll down to our extruder section, and we're looking for our rotation distance, which is currently set at 22.23. So we take 1.03 and we multiply it by 22.23, and we get another a new number that's 22.89. So 22.8969. Probably won't deal with the 4, but you know. Okay, so we're going to save and restart. We're going to come back up to our dashboard and quickly put this back up to 215 so it doesn't cool down. Meanwhile, we're going to take our tape, put it back at the 120 millimeter mark, and measure out another 120 millimeters on our filament. Because we just did a calculation, but we need to make sure that that calculation was correct. Not. So we're back up to temperature, and same thing. We've got our length set at 50. Our extrusion feed rate is 2. So we'll say extrude. As soon as we see it stop extruding, we'll hit extrude again. Which is right there, so we'll extrude again. Okay, so we're done extruding, and we're going to take a measurement again. And we are right at 20 millimeters. So we're now good to go as far as our E-step calibration is concerned. What I'm going to do is I'm just going to pop this top lever and release the pressure and just pull out that filament. And I can hold on to this filament for the next printer that I do, so I'll have the ability to do that. And you always just try and keep a scrap. But now what we're going to do is we're going to take our filament, put in our reverse Bowden tube over here. We're going to push it through. You'll feel when it goes into your sensor housing in your foot, because you should feel the little tick as it raises up the here we go. So right now it shows empty, and as I push forward, it'll roll up that bearing on top of the filament, which will trigger the end stop. And right there, it now has detected that there's filament. We're going to bring the filament forward until it comes out of our tube. So just get a decent little length coming through your tube. Try and get it straightened out a bit so that you can feed it in here. There we go. Got your tube down there. And we'll move this out of the way. And we'll come up and we'll do a load filament macro. And this is going to run a macro that will load the filament. Apparently, for whatever reason, it does a home to do that. Sets the target temperature to 230 degrees. So it makes sure that it's going to be warm enough for just about anything, because your ABS you should be able to push out there as well. And this is the default macro. I haven't changed or did anything to it yet. Here comes some filament out. Probably a little bit hard to see there. So let's so we got our little filament poop there. And I hear that it's done with its thing. So we'll take, it stays hot, which is interesting. It didn't start cooling off after doing the filament load. So I am going to drop that down a little bit. I'm going to go ahead and drop it down to 140. I want to cool it off all the way, because I know I'm going to try and hopefully do a test print roll. Get that out of the way. It might ooze a little bit. Actually, let's see. Talks about slicer setup, which we've got something for that already. And hey, print something like maybe a cube. So let me go over here to my Orca slicer. And what I'm going to do, because there's a preset in here for a V01, and I actually have one created for baby blue over here. I'm just going to grab that preset and I'm going to create a copy. Save this out. Try and save it. Oh, there we go. Save it. Change that to V02. Let's put KB3D on it. Build for KB3. Okay, so basically I just took my standard Orca slicer profile for the V01 and made a copy duplicate for this printer. And an Orca slicer, now that I have a new name for it, all I need to do is there's a little web symbol next to it. I can give it the IP address for this machine, which is 223. Say test. Came back confirmed. Say okay. Now I can do some type of test on this printer. So what I'm going to do is I'm going to grab file and LDO. Is there an LDO? I thought there was a startup guide. I thought somewhere they actually have the pre-slice cube, maybe not. So let me go to, not go to it on this printer or on this computer. That would be worthless. Let me go to printables real fast. Because I believe they just, I believe it's printables that they put it on. The LDO Cube. And we'll print an LDO Cube. that. Work a slicer, open file. Downloads, LDO Cube, delay, standard Voron configs. Probably drop the, oh, that's good. Upload and print, and it should start to go. There we go. So subsector, this is the mini stealth burner tool head. So this is the standard tool head, I'll say the standard default tool head for a V0. You could also do things like a dragon burner, and that will pretty much same setup. You'll still have the hot end fan, and the two cooling fans, but it gives you different options for your direct drive extruder. So this is a clockwork, well, the mini afterburner version of a Clockwork 2 extruder mechanism. But if you wanted to put a Sherpa Mini or say an Orbiter 2 with a filament sensor on top of it, you could do that with a Dragon Burner tool head. But this is the standard tool head for this printer. It's really not. I mean, this top portion right here is your extruder mechanism. And then right about where the two bolts come through is where the top of your tool head is, because these two bolts go right through the retainer for your tool head. But there's enough room on each side that you can get to the corners. Yeah, it's a direct drive tool head. So this is a reverse Bowden tube. So this is a 3mm inside diameter tube. And you've got your motor right here. Right, your motor's right here, your standard pancake motor. And then you've got your tool head board that sits right off the back of it. And then, like I said, there's these two screws that come in through the front that go through the whole thing and into the X-Carriage. And there's one screw in back that I can take off, and this whole tool head lifts off the X-Carriage. So 3 screws, and I can take the tool head off and take it over to the bench and work on it. Starting to think you might have your hot end set up wrong, since it doesn't need PTFE tube. On a stealth burner, there should be a small length of PTFE tube between the extruder portion and the hot end. It's not long, but there should be, maybe about that long. Uh-oh. That extruder not hot enough. So, all right, give me 1 second. Guess I should verify macro naming conventions real fast. Sorry for the desk scroll. Macros. X, Y, homing override. Print _ start. Okay. So yeah, that was the issue. So there there really isn't much. So like this print start here has the G28, G90 and go to a position, but it doesn't actually provide anything else. So what I'm going to do is come over here to baby blue and we're going to just copy and paste a couple of things, like our whole starting G-code macro. Yeah. Now, status heating won't work because I don't have, it's to change the lights, so I don't have that set up, or the status homing. We'll work on that later. The prime line. I haven't set up like camp or anything on either one of these, I don't think. Yep. So this should be good. Save, restart. I'll tell it that we want to push plastic again. Yeah, it's one of those things that I wish I had one of the printers here because then I could try and work through it. But yeah, it does get annoying when you're trying to do a mod that should be easy. Um, so Major Gamer Geek, I'm going to say yes and no. Okay. CAMP stands for Clipper Adaptive Mesh and Purging. So you can't do the adaptive mesh portion, but you can do the purging portion, which means it will, rather than purge in a specific place that you tell it, like I'm doing now, it will purge within a certain distance to the print itself. And I have that set up on my Rook, and actually Ragnarok and the Rook 2020. And I had it set up on the other Rook that is now with K2 Kevin. Yeah, so that's the deal is you can, without uh, a bed leveling sensor, you can't do the adaptive mesh portion, but you can do the purge portion. Unknown command, exclude object. Okay, we can go ahead and get that. Printer config. So we have include, square bracket, exclude object, square bracket, save and close. So that'll fix that error of unknown command, exclude object define. So I've got objects labeled. It's looking for the exclude object, but we didn't have that in the base file. So simple enough to add. Yeah, you can do manual bed meshing with paper. On a 120 by 120 bed size, and a Mike 6 bed at that, at 120 by 120, you're not going to need it. or you shouldn't need it. So the bed is at temp. The extruder's at the basic temp, which is 170. We'll go through and do a homing sequence next. Hey, look at that. Going to the front corner, it's going to heat up to the set temperature, which is 220. It's probably a little bit too hot. Drop it down once it gets started. Oh yeah, no worries, Mod Light. Oh, I might just jump on and see if there's anything on like Facebook Marketplace in the area where there's Max or a Cobra. It's not Cobra Max, it's the Cobra Neo, right? Okay. Let's grab this, bring you guys a little bit closer here. All right. Stop it. So, oh yeah, we're still way high. That either that or it's printing on a graph, which I doubt it. We're high. Okay, so we need to drop lower. Going to start curling. So I'm going to go ahead and stop this. So as you can see, we were quite a bit high. So I've dropped it down 0.15. Okay. And go save config, and then we'll start this back up again. Did it exclude object or object exclude? Bed didn't pull off too much. That'll help. Friends, I swear I'm trying to make it work nicer. Got a little bit of light in here. Looks like we're still high. We're going way too fast for this filament, because this is Polyterra. Too fast or too slow? That's not too bad. It's 50 millimeters per second. Yeah, so this is whoops, didn't realize I kicked that over. This is Polyterra. So Polyterra, you can't really go like real fast like we were starting to go. And I am also seeing a good deal of slack in our belts. Don't know how that came about. Hey guys, got a question for you. When we put our belts in there, did we tighten down the other side? I don't think we did. I think that's our issue right now. We may have our belts actually just pulled loose. Yeah. So printer go burr. We're getting close, but like I said, I think we're just going way too fast for the printer right now. But I'm going to need to let at least the tool head cool down some. And I need to recheck our belts because our belts are way floppy. And I have a feeling that I didn't tighten the maker nut on the tool head when we did the other side of the belt. So we get to actually see what it looks like when you take the tool off, like the entire tool head off, because that's what we're going to have to do. Got one screw in the back. Go ahead and take that out while we're letting things cool down. There's a makerspace event in Tulsa. If you don't mind, throw that information into the Discord. And like I said, I'm not too worried about the bed because the bed cools down ambiently anyhow. But I do want to let the tool head cool down at least below 50 before and the fan shuts off before I shut down the printer and unplug it so that I can take the tool head off. Tulsa Maker Fair. Okay, not a problem. You know what time of year it is? August? Okay. Okay. There's our fan. So I'm going to go ahead and do a shutdown. And I'll shut down the host. Give it a few seconds to kick through everything. Power off the printer. Unplug it. I'm just going to take this box and set it back here so that when I undo the tool head, I can just set it back on the box. So we took one screw out of the back. Undo these two screws, which are M3 by 35 button heads. Make sure you're holding on to your hot end. I guess the tool head board also connects into the X-Carriage. So I guess there's 5 total screws. 2 in the front and 3 in the back. fully out. There we go. And our tool head's off. Now we can check our belts, and yeah, this lower belt is almost pulled completely out. Hopefully there's enough there that I can get hold of it. Don't think that's going to happen. Ooh. I crashed you, did you? Printer's fine. I just knocked you guys off. Move that out of the way. I'm going to have to take off some screws to get to this to push that through. Great. That sucked. Oh, just dropped a tiny M2 screw. Good thing I got some extras. Yeah, so the issue that we've got here, you come out of there. Thank you. Is when I did these, I didn't tighten this screw back up. So now that we've cut them short, might be a booger to get through. So here's the other trick that we get to do. So you've cut your belt short as you're supposed to, and you go, oh, now I need to do maintenance on the tool head or the belts. How am I going to be able to get in there and get them loose so I can pull them back through? So we're going to undo our top bar here. We're going to loosen the front screw. And we're going to completely pull out the rear screw. And all of a sudden, you see how floppy that got? Now I can get this rear screw completely up and out. Rotate that around. Now I've got plenty of play that I can get in here and try and push this through some more. Hopefully. Do the whole wet noodle push thing. Grab the end of the belt with my forceps. Pull it through. Oops. It was lined up. Now I'm going to tighten this nut up, which is what I forgot to do the last time, which will effectively clamp my belt so that when I do the tension, it doesn't remove the tension. Now all I have to do is turn this back around, line it up, push it back, and redo this screw in the front, And it's easy to line up because it's going right down the front center channel. We'll tighten that one up. We'll put our beam back in. If I get the screw out of the way. Make sure you put the beam in with your nuts facing the side. There we go. 3 of the 4 here. We'll find one of the other ones. Two by 6 socket head cap screw. And I'll find the one that bounced around on the floor later. Thought that was it, but it's not. Hey, Hanigans. Thank you for the raid, my friend. Welcome on in, Raiders. Almost missed that. Thank you for coming in, Raiders. We're doing a quick little repair job on our printer because, well, apparently things were going so good that I didn't even realize that I forgot to tighten down my belt clamp. And so we actually were starting to print and our belts were getting loose and floppy. So now I need to do my little tensioning setup to make sure that we're tensioning the same still. What you're seeing me do right now is I'm loosening up the 4 screws on the motor, and that will allow me to adjust the belt tension using my knobs on the back of the printer. And let me so every once in a while, this app, you just need to close it out and restart it so you get more accurate readings. That wasn't good. Okay, that's pretty good. I'm a little bit, I'll say, higher on the setting, but that'll be good because those belts will ease up some over time. And let's get our tool head set back on here. That simple. And there's 2 screws in the front and 3 screws in the back that hold the tool head on. 3 that hold the tool head on, and then a second one or 2 more that'll hold the tool head board to the X-Carriage. Okay, now to get these put in. What technique is that, subsector? The tensioning of the belts? So what I was doing was setting my belts to, well, getting it 150 millimeters between the pulley points. Oh, darn it. So between the pulley point here and the front pulley, it should be 150 millimeters between the center of those 2 pulleys. And then you use an app, and what you're looking for is strumming your belts. They should be about 110 megahertz, and they need to be even. So once again, on this type of setup, I remove the tension from the motors. I can use the knobs on my motor mounts because the center part where the motor's physically attached can slide a couple of about 8 or 9 millimeters each way. And then when you're done, you just tighten this back down and it clamps the motor in place so it can't move anymore, and it'll keep your belt tension. but adjusting one belt will impact the other. So you do need to be mindful of that. So it's a bit of a side-to-side tweak that you have to do. Okay, so let's get connected back again. All right, good night, shenanigans. And we've got a raid from Chaos Drucker. Hello, hello, welcome on in, my friend. My friend from Germany. Welcome on in. And hello, Senberg and Chris SM92. Welcome on in. Let me jump screens here real fast. Sorry, give me 1 second. Sorry about that. My apologies. Welcome on in, everybody, to the Dragon's Den. My name is Digital Dragon 72, aka Luke. I am a 3D printing variety streamer here on Twitch, which means we do everything from printer assemblies, such as the Flying Bear Reborn 2, to modifications, like we've made a few on the Flying Bear Reborn 2. We've also built some Tridents, a couple of Vorons here, 2.4s. We've got our 0.1 over here. We do some prototyping, such as, the trad rack that's sitting on top of this 2.4, as well as the 0G Mercury 1. This is a full frame build with enclosure that was done during the closed beta of that program. So that's kind of what I mean by variety streamer. I also do a few cosplay helmets here and there. So, and today we've been working on our latest build, which is a Voron V0.2. It's the latest iteration of the V0 line. This is being built. The kit was provided by KB3D, who's my sponsor down there in the left corner of the screen. And they provided this kit. I'm building it on stream, and then we're going to send it to a maker in need somewhere in the continental United States. Or I should say North America. Yeah, welcome on in, everybody. Captain Chaos, thank you for the follow. Dragbox76, thank you for the follow. Yeah, I've got most of the parts cut for a Mercury 1 frame. I just need the 2020 verticals. I've got the extrusion. I just need to cut it and then start assembling that frame so I can do another one of the Mercury 1 0G, like the Pro size. All right, sounds good, Monlight. Take it easy. Take it easy. Thank you for the follow, PB1942. Tank, I appreciate it. I'm going to go ahead and fix the view real fast again. And yes, drop game does work. We do have a drop. Apparently, I still need to go on and take it off the cake for my birthday stream back in February. But so we were trying to do a print. It was printing. However, I noticed that my belts were getting loose, and I realized that we had tightened the belt clamp on one side and not on the other side. So when I tightened the belts up, it held a little bit, but as I started moving the print head around, the belts just came sliding out. So luckily we got it before a belt completely came off, because that would have been bad. So now we're gonna, well, try and print again. We've done through our initial checks, and we're to the point where it's time to do a print and see how things go. And while that starts heating up, go ahead and grab our latest little Flexi alligator for Toys for Tots off of the 2.4 called Kyber Dragon. This is in one of the Polymaker Starlights. I can't remember which one off the top of my head. Since earlier Zombie, really, it's just run through all the initial calibration. So our end stops working right, or our motor's moving in the right direction. We calibrated our E-steps for the extruder. We PID tuned the hot end and the heated bed. And now we figured, okay, this is an LDO kit. We downloaded the LDO Cube, and we tried to print it twice, and I stopped the second time because I noticed the belts were getting loose, which would be a bad thing. And I also think you'll see this start moving pretty fast when this starts up. I've got a pretty high profile set on. Basically what I did was I took my profile for my 01 and just made a copy of it and called it a V0.2 in Orca Slicer and sliced this file. But I'm also using Polyterra, which apparently trying to run at like 150 millimeters a second might not be a good idea. I don't know. That, and this also has just a Revo nozzle, so I can only do about 11 millimeters cubed a second. So I will slow this down a bit. Seriously. Oh, it's not. And this kit is, I'll say, 100% stock except for one change, and that is this right foot back here. We installed the option for a runout filament sensor in this foot. So at the back of this foot, there is a channel that the PTFE tube would normally go through. And in that channel, you drop an MR85 bearing, which is the same bearings you use in your BMG extruders on the shafts. You drop a bearing down in a slot, and then you mount a end stop right above that slot. And whenever you insert filament, it will roll that bearing up and trigger the end stop. So you have a filament runout detection in that rear right foot. Yep. All right. So it just did its purge, and now it's going to start laying down its first layer. And that's looking a lot better. Now that I'm done trying to smack things around, move this back a tad, and I can bring you guys forward a little bit so you can see this in a little bit closer in action. I promise I'll do my best not to smack you all off the camera stand again. And I'll shut that light off because I'm sure that's glaring in people's eyes. Hey, Luke's Player 1912. Welcome on in. Welcome on in. Yeah, no smacking the audience. So our speeds right now, it is spiking up to 200 millimeters a second, and it hits a max flow rate just over 12 as it's going through these fast moves. Wow. And as we, so right now we're just printing PLA in it. We will at some point here in the near future, probably on Tuesday, we'll start working on installing the skirts and some of the side panels and starting to build, enclose it. And then we'll run some ABS through it. So this is a lot that KB3D. So this is a standard. This is a standard LDO Voron V0.2 S1 kit. So this is a this is a standard kit from LDO, and you can get this from KB3D, of course, one of my sponsors, but you can also get it through any of the LDO resellers. So Fabrico, West 3D. I don't know if Tensor has the LDO kits or not, but this is a standard kit. Like I said, the only optional piece on here was adding that the runout sensor to the right leg, and I had to provide the parts. So I had a spare end stop. All you do is pop the lever off of your end stop, where you get the end stops without the levers, a wire on each of the outer pegs, and plug it in. And then it's a MR85 bearing, so you might have to get some of those off AliExpress or Amazon. But yeah, it's really well, Zombie, I'll tell you, we started this build last Saturday. So this is not very complex. You really, we're still not quote unquote done because we haven't put the panels on and everything and the top hat, but functionally this printer is done. It's printing, right? The rest I'll say is the cosmetics. So putting the skirts on the bottom, putting the panels on, that's kind of a cosmetics. You can run it like this as a PLA and PETG printer open air just fine. It's really not that complicated subsector or a zombie. And compared to the Trident, it's not as complex because the Trident, you're dealing with 3 lead screws, kinematic bed mounts. It's just a lot more parts and, you know, the biggest issue with the LDO kits is having to remember to check the LDO addendum notes when you're doing the build. Right, that's the biggest thing. The Voron build documents are amazing. They are really easy to look at, really easy to understand, and there's a great community out there on the Discord if you have any questions. It depends on your needs subsectors. So this kit, I want to say, is around $700, I believe. Let's pull it up and look at. All right, zombie, not a problem. So we look at the Voron. Look at the Vorons. We go over to the V0. It'd be great if you had it right at the top, but of course it's probably not going to be. So you can definitely self-source these. Okay, so the LDO Voron V0.2 S1 Rev 1 3D printer kit. That is this kit that we have right here. KB3D has it for $650. All right, not bad. $650 plus shipping. Right? And okay, yeah. If we go and we look at the, say, a Trident, part of me, it wants to look at other and see if that's where. Sorry. Let me just try and look under LDO. It might be easier. So the 2.4 kit at a 300 millimeter size is $1,400. So that's a little more than twice the cost of the V0 kit. But instead of a 120 by 120 by 120 build volume, you're going to be getting 300 by 300 by 270. Right? So it's a bigger build volume, like you said. The Trident should be about the same. We'll double check that real fast. So that's 2.4. I skipped the Trident. Well, that's weird. So he doesn't have the Trident kit listed there, but I know he has them. So let me I'm going to go find the Trident kit. Yeah, so it just depends on what size printer you need and what your use case is. If you're printing small things, then getting a big printer, especially if you're going to do ABS prints, you just think you have a larger volume of air chamber temp wise, you have to get heated up to the right temperature. Where on this smaller build, this could heat up a lot better and a lot quicker. I mean, granted, you got a smaller size heated bed that's trying to heat that chamber up, but this is getting to 110. The bigger bed gets to 110. It's just volume of air that you're trying to heat up. And the main difference is the Trident, you're going to have integrated lead screw motors where and you'll have 3 of those, the 2 front corners in the back, where with the 2.4, it's got the flying gantry, which means the bed's fixed at the bottom, but you've got 4 Z motors in the corners that are running belts to lift your gantry up. So it's different number of belts or different number of motors, different types of motors. The electronics should pretty much be the same. The gantries are the same. I don't know why it doesn't look like he has a Trident kit listed here. That's really weird. I'll have to ask him why he doesn't have a Trident kit. But yeah, I mean that's kind of where you're at. Is what's the size that you need and what are you going to be printing with it? If you're doing a lot of smaller prints, okay. If you're doing a lot of larger prints, like, so the nice thing with the V0, you can print all functional parts of any Voron on a V0. May not be able to do multiple parts on a plate, like you'll probably have to do some single parts on there. Like you can get the front fan shroud of a stealth burner on here at an angle, at a 45-degree angle, and print it. So you can print all the functional parts, but you can't do like the skirts and stuff like that for one of the bigger printers on this printer. But the skirts aren't a functional part to get the printer up in printing. So you get the printer up in printing, and then you can print out the skirts, the accent pieces, once you have your larger printer built. So my 0G Mercuries, my Trident, and my first 2.4 were all printed. All the main parts were printed on my Voron V0.1, and then the skirts were printed on my Ender 3 that was heavily modified. Because I had dual Z lead screws. I had X and Y linear rails. An all-metal hot end, Micro Swiss all-metal hot end. Direct drive Sherpa Mini. I had upgraded the board to a Big Tree Tech SKR Mini E3 V3. The build plate, I upgraded the build plate to a Mic 6 build plate with a Canovo silicone heater pad, 24-volt silicone heater pad. Right, so I had heavily modified it, but I was able to also put a Wham Bam hot box enclosure over it and get that enclosure up to mid 30s Celsius with that Mic 6 heated bed and be able to print my skirts out on it. So, oh, and I also had a Penda probe on it for bed mesh leveling. Now, mind you, this is the first print that we let go past the first couple of layers, because our belts are staying tight now, which is good. And I have not done any input shaping or any pressure advance or anything like that. Let me scroll through here real fast. We have a default square corner velocity. Under the extruder, we've got 0 pressure advance. So there's no tuned pressure, pre-tuned pressure advance. I saw no input shaping information unless it was already embedded down at the bottom. Sorry for the doom scroll, but I know any of the saved parameters are always down here at the bottom. So yeah, the only saved config parameters are the endstop position and our PID tunes for the hot end and the bed. So there's no input shaping, no pressure advance, and kind of technically I'm overrunning the hot end a little bit because it is peaking over 12 millimeters cubed per second, which is higher than a Revo can go reliably, but it's peaks. It's not a consistent. Yeah. Yeah, we're doing 200 millimeter moves. For some of these prints, we're getting up to 200 millimeters, and our acceleration is set at max acceleration is set at 5,000. Cell to decel. Yep. Yeah, this is bone stock. We haven't done any tuning on it whatsoever. We're just pushing plastic to make sure that functionally everything's working right. Keeps temp. So the color scheme on this is obviously a red frame. We decided to go with the primary color, which is this right here, and that is a Sparta 3D Sparkle Purple Mist, and our accent color is the Sparta 3D Sparkle Fluorescent Red. Both of these are polycarbonate ABS blend. So, yeah. So this is running a stock E3D Revo Voron edition, LDO edition, which means the heatsink is an anodized blue versus the Voron red that was made for the Voron team. It does come stock with the Kirigami anodized folded aluminum bed plate. Some of the creature comforts that it has underneath the Kirigami bed plate, we've got a pair of Wago connectors and a JST parallel board, which basically allows us to unscrew the 3 knurled nuts at the bottom, lift the bed up, undo the wires and take the bed off without having to undo all the wires through the cable chain and all the way back to the board. It does have a toolhead board, so all of the stuff on the toolhead goes to a common toolhead board with a 14-pin connector that goes back to the back panel deck here. That back panel deck, it's called the Picobillical, and it's got a Raspberry Pi RP2040 chip on it. So this panel that goes between the two motors at the back deck here is an actual MCU. So it controls everything on here minus the stepper motor. The stepper motor does have a pass-through back to the main SKR Pico board. The kit comes with all of that. It comes with the Big Tree Tech SKR Pico controller. The only thing it doesn't come with is your host computer, a Raspberry Pi. It does come with a little board that plugs into your Raspberry Pi GPIO pins that allows you to take and apply power to the Raspberry Pi board, as well as it has a FPC connector that allows you to run a provided FPC cable between that connector on your Raspberry Pi and a connector on your Picobillical board, and that connects to the ADXL, which will enable us to do input shaper. So we'll connect this wire up. We'll do some additional settings to set up input shaper on our Raspberry Pi, and then we can run input shaping without any issues. And those of you that can hear me, we do have an ad break, so I'm just going to hang on for a couple of minutes, 45 more seconds. And welcome on back, everybody, from the ad break. So we were just talking about the specs on the printer. The LDO design actually calls for using a Raspberry Pi 2W, because the 2W you can actually run input shaping with. The standard Raspberry Pi 0W is not strong enough to run input shaping by itself. And it specs out having a like a 4-port USB expander board that the Raspberry Pi Zero would mount onto using the GPIO pins, and then have this other board at the top for the power and the ADXL. I have a Raspberry Pi 2W that I could have put on this. However, the kit, because it does not ship with Raspberry Pis currently, because of the cost and the scarcity of them still, didn't have that expander board either. And the only place I could find them was at a couple of locations in the UK. So there's no way I could get them here in time. So I'm using a Raspberry Pi 3B Plus on this right now, which can do the input shaper and stuff like that. How fast do I have this running? This can peak up at times to 200 millimeters a second when it's doing a full wall. So as it's doing a full exterior wall without having to do any of the jogs for the logo, it can spike up to 200 millimeters a second. fact, it's hitting that when it's doing the grid infill right now. So Orca Slicer settings for this on my speeds is 50 for the first layer, 105 for the first layer infill, 120 on the outer walls, 200 millimeters per second for the inner walls. So that means if you're doing 3 walls, the 2 inners will be done at 200, and only the 1 exterior wall will be done at 120, and that just slows it down for, you know, a nicer exterior finish. 200 millimeters a second for sparse infill and internal solid infill. 100 for top surface and 100 for gap infill. So those are my speeds and feeds right now. Well, and that's the thing, Subsector. I mean, I jump on at night, or really the majority of this was built last Saturday, and I did it on like a 7 or 8 hour stream. A lot of people work on this, and the first thing they do is just get the frame with the Z in place, because the first couple of things that you'll work on after you get your rails prepped is getting your Z and these 2 cross beams in place, parallel square. But if you just do it, you know, an hour each night, you'd be surprised. You can get this done in a week. Yeah, yeah. You do need to be a little bit organized with your parts. That's why I would suggest getting or reusing a, you know, like a Plano parts bin. So, you know, doing like this. This was the hardware kit that for Voron Trident. So I'm not even looking at this. I just took all the fastener bags and just put them in here in kind of size order so that they're easy enough to find. And I just left them in the bag. I didn't even bother taking them out. Right? So it just made it a little bit easier to find the baggies versus where I've done builds and I've just had all the baggies sitting here in a pile and you're trying to rifle through them. But yeah, it's not hard. I mean, I watched you do your SVO5. I mean, yeah, your belts were run because the SVO5, the base was built, like the base frame was built and the top frame was built, right? You just had to add the uprights and a couple other things, if I remember right. So here you're doing a little bit more, but I mean, the instructions are really, really straightforward. We'll go back to this view and we'll switch over to the PDF real fast. And, you know, really, the diagrams are really straightforward and it's step by step. So even if you go through and you do just a couple of pages, you know, find these 2 pieces, slip them in, put in 4 screws. It calls out the screws that you're going to use. It's pretty straightforward and easy enough. And even, so this is what I found out when I was building my airplane, right? So I've got drawings that are a little bit more detailed than this, right, for my airplane build, but it's really work a step. And if all I get done is 1 step that day, that's great. And sometimes that 1 step that day is deburring both sides of 200 holes on a sheet of aluminum. And there's been times when I've sat in the chair in front of the TV with the garbage can, the kitchen garbage can sitting there in front of me, and I'm just deburring tools or deburring holes on sheet metal, right? So that I can have the parts prepped for the next day where I'm lining everything up with clecos and riveting things, right? And you built RC cars and planes and stuff like that. So yeah, it's simply, don't worry about trying to do this speed build. Like if I really, really wanted to, I could start Saturday and I can either go straight and build this and get it printing on the same day, or at least doing it a Saturday and Sunday and have it printing in Sunday. But I've built a couple of these, right? But for somebody new that's never built one, I'll tell you what I did. I watched Steve builds. I watched Nero, and I watched them build, a V0 printer, right? So I kind of understood. Then I looked at the manual and read through the manual while I was waiting to source parts because my V01 was built self-sourced, right? So it's doable. I know you've got the skills to do it. It's just take your time. I build these fairly quickly on stream, but that's because I've got another 2.4 sitting here on the floor for Chewy to build that I'm going to build on stream and then get it to Chewy. I've got a salad fork on the way. I've got a black box coming sometime in November. Like hopefully I'll get it, around Thanksgiving time or maybe a little bit after. Right now there's a snafu right now with the transfer of the Fusion files from Mark to Chris. So it's more of, yeah, sometimes like this could take, well, and it also depends too, like Modbot does his streams one day a week. So he streams Wednesdays. And then he releases a video on Saturdays on his YouTube channel. So yeah, if you're only streaming once a week, it's going to take a lot longer, right? I stream 3 days a week, 2 evenings and 1 Saturday. So it's normally, you can make some pretty good progress when you're doing the same build 3 days a week. Nero used to have 2 different builds going. So he'd have one build that he's working on like one day in the middle of the week, and then another build he's working on Saturday nights. And I've done that once, and I'm not going to do that again probably, because having 2 different builds going on at the same time is a little schizophrenic. And with the way my setup is, I would have to take stuff off the bench, go put it somewhere else, put the other project up on the bench, and just trying to get everything set up and keep track of all the fasteners and everything. It would be a mess. So yeah, I would just definitely say, if you want to, you can build one of these. Take your time. Don't worry about getting it done in a couple of weeks, right? Take your time and build it as you have time. And you don't have to stream it either, because streaming it takes a lot longer as well. Because you're stopping and chatting and you get sidetracked with chat. So everything takes at least twice as long when you're streaming it. And Eagle Brett, if you want to do something else, so like on these, they highly, highly suggest you print in ABS, ASA, or another high temp, low creep material, right? You don't print these in PLA unless you have no intention of enclosing them and you're going to keep them like this, open air. Then you can print in PLA or PETG. But if you're going to enclose them, you've got to print them in a high temp filament, all the printed parts, okay? That's the caveat. Now you can do a printed forward. You can, there's people that sell the parts on Etsy. You can contact somebody like me that's probably just going to charge you for shipping, because I've got filament for days. It's just time. Ask Modlight. I've shipped quite a few things to him. But yeah, these prints these builds are pretty cool. And what I would say is do something like a Rook, right? You can get a Rook kit from West 3D or Fabrico, and rumor has it that LDO is coming out with a Rook kit as well, right? You can build a Rook, which is a mostly printed 3D printer. I've built 3 of them already. I'm supposed to also have an LDO Rook, but I'm not sure if Jason remembers, right? You can do the Rook 2020, which gets you used to working with the extrusions and the printed parts, right? But something like that is, I think the Rook kit from Fabrico is like $299. It uses the same size bed as this. It's about the same size as this printer. It uses a slightly different tool head, but guess what? It's got a 4010 fan in the front, and instead of having the blowers on the side, the blowers get raised up higher, and it's a Bowden system, right? For a person building a printer for the first time, and you want to get used to building a printer, or not even used to it, but you want to try your hand at building a printer, and your need is not for a high temp printer, build a Rook. They're a fun little build. They really are. And they're really quick. They're really quick. They're not that complex, and the Rook is fun. K2 Kevin will tell you. I gave him Gold Dragon, which was my first Rook Mark I that I built, self-sourced, and I gave it to him at ERF, and he has replaced all the gold parts with orange, and now renamed it as Orange Crush, right? And there's plenty of mods out there too, so you can build it and make it your own, aka Pimp My Printer, and it's a cool little printer. And if you want it to be even more rigid, you can do a Rook 2020, which adds, like I said, a 2020 extrusion frame, and it just makes it that much more rigid. And yeah, they're fun little printers. Hey, Layer by Layer, welcome in. K2 Kevin, thanks for sneaking in here. Tech Jeeper, welcome in as well. So this is our first successful print off this printer. And really, K2 Kevin and Layer by Layer, I'm not sure how long you guys have been lurking in here, but what happened was I started trying to print, and I happened to be looking at the belts going, why are my belts flexing? Like every time it would go through a movement, the belts would bulge out the side. I'm like, oh my goodness, stop. We let things cool down. We unplugged it. Yeah, you just got in. So I'm going to move back here a bit. So we had to do a little bit of surgery. And by surgery, I mean, we had to take the tool head off because I forgot to tighten the belt clamps down on the other side. So when we started off, we clamped the belts on the right-hand side. We ran our belts. We pulled it through. We got them tight initially by hand. And I forgot to tighten the clamp on the left side. So when I tensioned it, it wasn't too bad. But it was when I started moving it at 200 millimeters a second that it started pulling that belt out through the clamp. So luckily I got it before I couldn't get it back in there, but we had to take the tool head off, which because of the Picobillical and stuff, there's 3 screws in the back, 2 screws in the front, and we lifted the whole tool head up, and we didn't even disconnect the Bowden tube or anything. I just put a box back here, we picked it up and sat it down, right? And the only thing I needed to do was I took out the 2 screws holding this bar in, took this bar out, I loosened the screw that's in the front of this, and I took this screw out, which enabled me to take this whole part, turn it 90 degrees. Now I have plenty of belt slack. I took the X-Carriage off and pushed enough of the belt through that I could grab it with the forceps. Pulled the belt out again, got them even, put the X-Carriage back on and tightened that belt clamp down, rotated this back around, screwed it back in, screwed this in, screwed these in, 5 more, set that back up there, 5 more bolts. Now we're setting the tension on our belts again. That was it. And I mean, it was probably, what, 10, 15 minutes, folks? Just going through and explaining it as I was doing it. Now, if you have panels on it, of course, you got to take some panels off to be able to pop these off, but that's not too bad. If you need to loosen the belts, the nice thing is you can pop one side off, whichever belt side that you need to loosen, and it's easy enough to do. So the print bed, and we just hit an ad break, so let me wait for the ad break to finish, Eagle Brett. I'm not sure if you can hear me, so give me a minute to let that ad finish. And welcome back. Sorry, folks. I was trying not to talk because I don't know if Eagle Brett was subscribed or not. Thank you, Subsector, for gifting Eagle Brett a gift sub. I appreciate that. And so the bed size here is 120 by 120, and we're at about 118 in height, right? So pretty good build volume. We're going to go ahead and snap this off. Peel off our little purge line. And I will show you that what can you print on this thing. So there's a monster jar from Creatix Brit. That'll fit on there. You like Eastman? Well, this is a Babu Frick resin print, but that'll fit on there. You'd be surprised. Like I'm printing at Earth. I had my Rook 2020, which once again is the same build size, and I was printing 3 chameleons. And if I work it right, I could probably get 4 chameleons on this printed bed. The Flexi Alligator here, there's 2 versions. There's one where he's laid out straight on the bed, and there's one where he's curved. like that. So I can print one of these on this bed, one at a time, but, and I'm not going to print a flexi like this at 200 millimeters a second. I'm going to slow it way down because every time I try and do these at high speed, I will rip one off and it causes a mess. But you'd be surprised what you can put on a 120 by 120 bed. Um, the Babu Frick, I think that's an Eastman one. It may be photo cement. I don't know. It may be photo cement. You can put a lot of photo cement bus on here, right? So let's take a look at our print. So there's our bottom. Trying to find my right focal length here. So the bottom's looking good. Our sides. You work with me in focus. Our sides are looking good. Top's looking good. Yeah, now this is the, what is this? The slate. This is Polyterra marble slate gray, right? And I do see some artifacts like right up here in this corner, if I can get it to focus. I really wish I could figure this damn focal length out. Really? Why won't you focus? Anyhow, we do have, there's some few artifacts on this, but it's really, for being a first print off of a completely untuned printer, this is awesome. And especially since we were running it fast as if it was on a tuned printer. Right? Yeah, it's focusing on my hand, not the object. And it's probably the lighting too. It's crappy lighting right where this is at. But yeah, I don't know if I can get it close enough to the main camera for it to pick up, but we'll see. And right up here in this corner by my finger is where I'm seeing a little bit of deviation just coming off of the, yeah, my lighting sucks. I need to work on my lighting. But like I said, for a first print and running it as fast as I was, like if I slowed it down, this would probably look a lot smoother because I was overrunning the hot end, right? We were spiking over 12 millimeters a second, or 12 millimeters cube per second, which is the theoretical limit of the E3D Revo, the standard Revo, right? So that's why you can get closer to that by running it hotter, which is why I was running it at 220. But if I dropped it down a little bit, I could probably get an even better cube than this. So yeah, I'm impressed with the first print off of this and as fast as we were running it. Okay, where are we at? You know, it's kind of a good idea when you think about it. Small little printer like that to do busts and stuff. You have to have a Pi. So yes, to run this in Clipper, which most Vorons are designed to run Clipper, you would have a Raspberry Pi. But then again, most people, even on Marlin, are running, you know, Octoprint, which would require a Raspberry Pi. Or some sort. Like you can run a La Potato. In fact, I am running my Bugaboo 210, which is probably another good a good printer to start off with. It's just not as well documented as the Rook, but it uses a ender bed, right? An ender size bed. That prints really well, and I have that running off of a Banana Pi 0 M2, which is about like a Raspberry Pi 3B, not a 3B plus, but like a 3B. And performance wise, yeah, I'm either under or over the focal distance on that one. So I tuned it for PID and E-steps, but I haven't tuned it with input shaper or pressure advance yet. And input shaper and pressure advance is what's going to allow me to tweak for speed, as well as the way that it handles corners. And that's where, like I said, I don't know if I can get it to really show up well. But right above my finger, there's some print artifacts right there as it's coming out of the corner. Really wish I could figure out. There we go. Oh, there we go. You see those print artifacts at the corner? Or did you? Hey, Pez. Just darn you. Yeah, you saw it for a second. Now I know why people use gloves on their hands. I feel like I'm almost there to get it. Come on. There we go. There we go. So you see those artifacts in that top left corner? It's like that on every corner. And that's as it's coming out of a corner. So that's a pressure advance issue. But overall, you can see a couple of spots where it's not completely filled in. And that's because we were running really, really fast. And you're also seeing this line here as it transitions from an angle to a solid line. And that's also right about the time where it starts doing its jump into the logo. And all of that can be taken care of with input shaping and pressure advance tuning. And we've done E-steps, but we haven't done extrusion multiply. Right, so that's why I mean it's not completely tuned. Yes, we tuned the hot end, or we tuned the heaters, and we tuned the E-steps. So when I say push 100 millimeters of filament, it pushes 100 millimeters of filament. But I haven't set the extrusion multiplier so that I'm getting a consistent layer, right? And so there's tests that you can do. And that's the thing I like about Orca Slicer is I can now go in and run specific tests through Orca Slicer to do a temp tower, to do flow measurements for my extrusion multiplier, right? And all of that. And those extrusion multiplier tests will fit on this bed. So yeah, that'd be nice, K2. So yeah, we've got a printer and our printer is printing. And we're not loosening, we're not having any issues with the belts after we properly clamp the belts down so that they don't start coming undone when we start trying to run the printer fast. So let me get this out of the way. And so what we can do is start the other 6-hour print on the 2.4 behind me. I'm going to go into Orca Slicer, and there's a calibration tab and a flow rate. So we're going to go with pass 1. It's just a smidge too big. So let's scale it down. %, that works. So in Orca Slicer, they've got 2 different types. And do I even have Orca Slicer on this yet? Orca Slicer, yes. Orca. I do not. Shame on me. So while this print's heating up, we'll do try and do a quick download of Orca Slicer. Orca Slicer. Slicer latest. Oh, I do not want the beta. No beta. One point 7 assets. $1. Hogs took the towels out in the yard again. Okay. All right. We'll see you back in a second. So while while this is starting to heat back up for the next print, which is a test print, we just downloaded Orca Slicer. Go ahead and install that. Oh, let's sit back down, folks. What? That was weird. and not expected. Yep, that's not going to go out right. Cancel that, and I have a feeling that it's I have a feeling I need to look at the G code that was created, that it might have created the G code wrong, which happens sometimes. So see, G code files, right click, edit file. Setting the parameters for each one of those little items that you saw. Print start food. We'll try that again. I don't know why that just seemed like it did not home to the front right. It caught on something. Try that again. Don't know what happened, but it's working better now. So what I'm going to do is I'm just going to show a different window. And this is Orca Slicer. And this is the base setup for Orca Slicer. And all I've got is a V01. I'm not going to run any of this code. what I wanted to show you is you have a calibration tab up here. You can click that calibration tab and you can do temperature towers, and it automatically creates a temperature tower based on whichever filament you're going to use. And you can give it a starting range and an ending range. Say OK, and it will prep that and have all the G code in place to do the stepped tower, right? Now you can go in here and do project, because you want to do a new project whenever you do these calibrations to clear out the old stuff. There's a lot of stuff that needs to discard in the background. Next calibration, and this is what we're doing now, is the flow rate pass 1, right? And what this does is it sets up 9 separate tabs, and I just had to come in here and I scaled it down to 90 uniformly so it fit on the bed. And what this is doing, I'll have to bring up the tutorial in a second, but it's doing little swatches basically, and each one is being configured for a different extrusion multiplier rating. And what it's doing is it's taking your default that's listed for your in this case generic PLA. If I click on this, click on advanced, see everything. My current flow ratio is set to 0.98. So we'll do this print, we'll take a look at it, we'll figure out which one has the best look on the surface, and we'll use that to calculate our next, we'll do the calculation and update our flow rate. Then we'll run the second pass, and the second pass is going to start at that flow rate. So you want to error to the high side, because it's going to start at that flow rate and do 10 steps down. So each one of these is 5% or plus or minus 5, right? And so this will give you the ability to fine tune it even more. And then you'll have the extrusion multiplier set for this filament. Okay? Once again, we're setting the extrusion multiplier for Polyterra, which is a matte filament. If I switch over to a silk, that silk gold that we were using when we did our initial calibration steps, it may grab that filament slightly differently because it's going to be slicker and shinier, right? So each filament, you would have a different grab or pull in the extruder. If you've ever used, think about, okay, a silk and then like a Capricorn shiny rainbow. Has a lot of glitter in it, or glitter type particles, or a protopasta, which I find a lot of protopastas being very textured. Like it almost feels like you're running your finger down tile grout sometimes, right? Those are going to have different extrusion multipliers. So you would have to do this for each, I would say at least type of filament, like PLA standard polymaker, they should all be the same. PLA silk is going to be a slightly different setup. Polyterra might be different than the standard PLA Pro, right? So that's where you'd want to redo this for a filament, right? Oh, hey, Subsector. Been lurking for 4 hours. Time to say hi. Oh, hey, Daddy Wazzy. So I'm just kind of showing off some of the calibration tests. So you'll run pass 1, you'll make some adjustments, you'll run pass 2, which will be a different pattern. And you'll see this pattern is now 10 swatches because once again, it goes from 0 to -10, right? Changes can color, but not as much. It's not, I found it not to be really major of a change. Like you're not going to get a 2 or 3, like you're not going to go from 98 to 96 just doing going from blue to red in Polymaker Pro PLA, right? You've got a pressure advance test, and there's different types that you can do. That's, oh, it's not doing the pop-up, but let me go over to the full window so you can see the pop-up. Okay, so on your pressure advance test, you can tell it whether you're using a direct drive or a Bowden, and whether you want to do a pressure advance tower, a pressure advance line, which is where it does a series of lines, or the pattern. If you do the pattern, which is the one they suggest, awesome, that showed up like that tiny little, I don't know why it, for whatever reason, it keeps doing this, and I don't think it's going to slice. Oh, there we go. So this is what that slice print looks like. And what you're going to be looking for is the crispest arrow corner here where it comes to a point without rounding over, right? So it'll do different pressure advance parameters here, and you're just looking for the closest one where it doesn't round over. Then you'll have the Orca tolerance test. So this is their little test, I'll say test cube. So you're testing for different nut sizes. I wanted to say, I thought there was more than just the nut sizes, I guess not. You'll also have max flow rate. This is your little racetrack pattern. Right? This gives you a little racetrack pattern, and you're looking for the max flow rate. So how quickly and how much plastic can I push? And like I said, the theoretical limit for the E3D Revo, standard Revo, is 12 cubic millimeters per second. I put a ByQ H2 V2S light on the Ender XY, and I was getting almost 40 millimeters cubed per second with standard Polymaker PLA at, I think, 220 or 225, and it was hitting flow rates up to 40 millimeters cubed per second. And that was with a 0.4 nozzle. And it says it can go up to 43 with a 0.6 nozzle. So you can do this for every type of filament you're using, right? It depends on, like, so it depends on the model, right? If you're doing an organic type of model like a bust, you may not see that many issues in the detail unless there's really fine detail in it, right? If you are doing precision parts that are meant to connect together to make a larger part, you definitely want to do a lot of tuning on that to make sure that your tolerances are good. And you may not want to run it fast at that point. You may want to slow it down a lot, right? You also have the VFA test, and this is very fine artifact or vertical fine artifact. This is a test to, yeah, it's another test that you can do. Once again, it's just slowly digging in and just more and more fine tuning, right? Now, here's a key. I haven't done input shaping. I go through and I do my extrusion multiplier, my pressure advance, my flow rate, and all of that. And then I go through and do input shaper. I need to go through and redo all my tuning again. Because your input shaper is going to fundamentally change the way the printer reacts. So it will impact your pressure advance. It will impact some of the other things, because pressure advance is changing the amount of pressure it's accounting for the pressure of the melted filament in your nozzle, and you're tuning it for the best visual effect. When you change input shaper is changing your acceleration and deceleration into a corner, and which is why you would need to go and recalibrate your pressure advance after you've done input shaper. That's why I'm doing this, and I'm kind of like, I'm doing this to really show you guys, but I really need to do input shaper, right? And we'll get into input shaper Tuesday night, because I just realized it just ticked into 10 o'clock, and I've been streaming for another 4 hours today. So end result, without any tuning, any real tuning other than head tuning and E-steps for the extruder, once again, this is okay. Seriously, did it earlier. Focus. Closer to the one you love. I swear the focal length should be like back here. Oh, oh, come on. We almost had you earlier. Okay, Liz. Come on, you little shit. Sorry, you can do it. There we go. For being a first print, and I was running it at 200 millimeters a second, 120 for the outer walls. I can live with this as a first print off of a brand new printer. Top. The top solid we were running again at 120. The extrusion multiplier probably is what we're going to work on right now. That'll help fill in those gaps and give us a better, cleaner top surface. So you're building your printer on stream, so you're going to continue to work on your Cocoa Press on stream tonight? Thank you, Liz. Yeah. Yeah, I'm fully impressed with this. But then again, you know, my little Vorons, like I said, well, my Vorons and my Rooks are amazing. I've been sitting there ever since I got back from Earth. They've been sitting there on the kitchen on one of the dining room tables, and they've been churning out chameleons and penguins. And I've been doing the alligators and the dolphins on the bigger printers because I can normally do them a couple at a time, you know. And I got one of each color of Starlight, and I'm just running prints in Starlight for these. I need to actually figure out where I can take them so that I can get them to one of the, there's normally a local guy here, probably about 40 minutes away, that I could go take them and drop them off at. And thank you, Mighty Bean. So once again, this is a LDO Motors Voron V0.2 S1 kit. It was provided to me by KB3D at Earth, and I brought it home with me to build on stream. It is a red frame, and the color scheme is Sparta 3D Sparkle Purple Mist and Sparta 3D Sparkle Fluorescent Red. And the filament is their polycarbonate ABS blend. Okay. This is a standard kit. The only thing I've done is I had to provide my own Raspberry Pi for it. So it's running a Raspberry Pi 3B. And on the rear right leg over here, where the filament tube goes in, normally it's a standard leg and your PTFE tube goes all the way through that leg up to the top. This leg has a press fit. Oh. And we're waiting for another ad to finish because I don't know if Mighty Bean's a subscriber or not. Another 30 seconds or so, and I'll continue. Other thing I need to do is my roller fan is not kicking. Means I wonder if it right. Okay, ads are back. So the only thing I've done is this right rear leg. I've got a modified leg. It's actually out in the Voron 0.2 files, but it's got an added length of spot in it that you can put an ECAS fitting in. And it has a slot where you can put an MR85 bearing, which is the same bearing that's used to support the shafts of your BMG, the white or black large plastic gear. So you drop one of those down in there and you put an end stop on top of it without the lever, and it becomes a filament run-out sensor. That's the only thing that I've changed on here from the stock kit so far. Now what I need to do is the, here we go. So I don't have any of the panels on here, which is good because I just looked and my controller fan back here that should be cooling off the Raspberry Pi is not functioning. And it's because looking here, we've got the hot end fan and the part cooling fan identified. Now these particular things right here are for the SKR Pico board, and there's a note that says that the LDO Picobillical configuration further down in this file, which is the board that's mounted between the motors back here that feeds the tool head, actually changes the pins for those. But the controller fan down here in this section is comment it out. So let me uncomment this. And now, after I do a save and restart, whenever there's power applied to the heat bed, the controller fan will actually work. And of course, that was great because I did a restart before dropping the bed. Unable to parse cycle time. I don't have a control. Unable to parse option cycle time. Fan. Didn't I? Fan is this. I didn't change that. That would be overwritten by the Picobillical section down here. Hey, if it's not one thing, it's another. Macro, big. What I'm doing right now is looking through the printer config for my other printer. Power, kickstart time, off below, cycle time. So that would cycle time thing. Don't know why that would be thinking anything. Is the line above what you uncomment? Yeah, that's what I'm saying. It's in this section here, but I didn't change any of that. I just uncommented this section. Oh, there's an extra space there. Syntax kills you every time. Yay. Just going to home the Z to drop this down. But what we're doing in this print, not like that one. Come up here to this screen. So on this print, we're at, yeah, so this is 0. This is the standard extrusion multiplier set in the slicer. Plus 5, 10, 15, 20, minus 5, minus 10, minus 15, minus 20. So what we'd be looking for is which one gives us the best surface finish at both a look and a feel. Like you can see down here, you're getting some tears and some gaps. So this is way too low. Don't look at the numbers. We're looking at the surface of these pieces here. So you look at these, figure out which one you like the best and had the best surface finish. And then that would be the one that you would start with and tweak from there. And so 20, it kind of looks real smooth on the middle, but you're starting to get bulges in the corner. Still a little bit of a bulge. I kind of really like 10 and 5, both from a full surface finish and the bulging around the edges, because we can fix the bulging with pressure advance. So I would start with 10. So I'd use 10, figure out my new extrusion multiplier, put that in and save it in the slicer, then go and configure the second pass, which will do 10 of these swatches, and it'll start at like 0 and work its way to -10. So you always want to err to the higher side, because then it's going to start at that number and work its way down, 1% or 1% at a time. So yeah, but I'll work that at another stream. It's now 10:15. I may just work on this off stream, and when we come back in on Tuesday, we'll maybe add some skirts, do some other prettier, make it pretty, and do some more printing on Tuesday. So thanks everybody for being here with me tonight. I know it was kind of an impromptu. You're not used to having me on Saturday nights. As Zombie started, Zombie Hedgehog. No Zombie Hedgehog yet. 3 more minutes? 3 more minutes. Starts in 3 minutes. Okay. Hang out with us, Shadell. Go over and heckle Zombie a little bit. I want us to go over and heckle Zombie. But yeah, I'm looking at this saying we've got another good printer on our hands. We're going to be working on panels and skirts and stuff. So yeah. Let's talk about why your tests always result in no change. What do you mean? Well, calibration and 0 is always best. Well, it could be. It could be. Once again, depending on what filament you're using, like I'm getting this result with this Polyterra matte slate gray. I could probably take this off and put a different Polymaker filament on here and get a different result. And maybe something else looks better than this does. And some of this is, it's qualitative, right? Not quantitative. It's which one do you feel looks better, right? Which one do you feel is giving you the best result? And everybody that looks at it may have a slightly different opinion on which one looks better. Especially when you're looking at just a swatch versus if I ran a bus, it may look perfect, right? So it all depends. And besides, KT, you ran a flow test on the Rook Mark 1, and it was chef's kiss already. I had tuned it. Polyterra's Pet G's Bamboo Studio is well, and yeah, so Bamboo Labs is tuning it because it's using its LiDAR sensors on the tool head, and that's why it does that little pattern at the beginning of the print, and even can adjust even if you take that pattern out. I believe they're using that real-time data to get a better flow rate for you. So and that's the interesting piece about the Bamboo Labs that they're bringing to the equation. Like, oh well, we've got they're using a strain gauge on the bed for the auto Z leveling. Somebody, we got tap, we've got the nozzle probing of the Mark IV. We're using a strain gauge on the tool head. You've got beacon and all this stuff. So we've had probes for doing the ABL for so long that we're getting good meshes. As long as you can set your offset, you're good. But with the Bamboo, it does a lot of that for you based on the added sensors that they've put in place. And if you can add the additional sensors and get them calibrated in your software, you can do a lot of that on the fly, right? Yeah, you range from 1 to -6. Yeah, and that's the thing is, and so you have the ability to go in and create a profile for every different type of filament for every printer. So you could have Polyterra slate gray and have different configuration settings for 5 different printers because each of those printers has a slightly different, extruder hot end combo, and you're going to have different results for each one. So you can really get it tailored down. Um, yeah, yeah. All right, and it sounds like the Hedgehog is up and running. So really, we're going there to check out, hang out with Liz. Right. Let's be honest. Um, so it wouldn't be the Z and Z show without the Z. So let's go over and go hang out with Zombie. I believe he still has the starting screen going, but guys, I'll be honest with you. I've had a couple of bottles of water and I need to get some food in me, and yeah. So thank you all for hanging out with me. Once I figured out that my issue earlier today was just that plug and it wasn't seated all the way, it was killing me, like ready to get this thing going. And I didn't want to go through and do all these first checks off stream because I know every time I do these first checks on a printer, there's somebody new in the stream that's learning from it. So thank you everybody for being here and hanging out with me today. We'll see you all on Tuesday. Go with me on the raid over to Zombie Hedgehog so we can see the Z and Said show and hang out with Pez Liz, also a great, overall person and a great creator. And I would be doing some shout outs, but my mods left and yeah, folks, I'm wearing down. So I'm going to take off. Thanks, everybody. Oh, MTB Matt, thanks for stopping in. And I'm going to get the raid started here. And yes, that's now started for the countdown. Please, everybody, go with me on the raid. And thank you very much. We'll see you on Tuesday. And we'll chat with you guys later on. Thanks again. Bye now.